Hello everyone, and today's video is about the multiplication rule and conditional probability. We're going to do a couple of problems, one of which is sourced from a table used in a previous video, which is found on page 150 in the text. So our goals for the day are to be able to identify the multiplication rule, identify what conditional probability is and when applying it is appropriate, and then we're going to calculate some examples using both the multiplication rule and conditional probability. So the multiplication rule states, very formally, that the probability of A and B is equal to the probability of A times the probability of B given that A occurred. And just to make a note of that, this is probability of B given that A occurred. So if I want to do a quick multiplication rule example, first I have to identify whether I'm sampling with or without replacement. So with replacement, my n remains constant throughout. Without replacement, it's going to change every time I pick, in this case, a marble out of my bag. So to do an example of with replacement, so I'll say with replacement, if I want the probability of picking a red marble and then picking a green marble, I have to multiply P of red times P of green given that I did pick a red. So in this case we have 12 marbles and 3 red ones. So the probability of red is 3 out of 12, and if I pick it out and then put it back in the bag, that's with replacement, then I would multiply the P of green, which is also 3 out of 12, and I would end up with 9 out of 144. Now, if I were to conduct the exact same trial, except without replacement this time, I would have to calculate it like this. So if I want to do without replacement, it's probability of red, which is still 3 of 12, times probability of green, assuming that I picked a red marble and it's now sitting outside my bag, so there's 3 marbles that are green, but there's only 11 marbles in the bag. So this would result in 9 out of 132. So as you can see, testing with or without replacement will change the probability slightly when it comes to the multiplication rule. The next topic I want to talk to you about is conditional probability, and it is defined formally as the probability of B given that A occurred divided by the probability of A. And this is the formal definition, but as we do an example, we'll see a little bit of an easier way to do it, and I'll show you the proper formal mathematical way to do it as well. So we're going to do an example using this table from the book. It's on page 150. So if I wanted to calculate the probability of a positive test result given that a subject uses drugs, what I would look for is first the positive test result and the subject uses drugs where they meet, which is right there with 44. So that's 44 out of 1,000 subjects in the total test, and I would divide that by the total of subjects who use drugs in the entire test, which is 50 out of 1,000. So to do that, I would simply multiply by the reciprocal, so I've got 44 out of 1,000 times 1,000 over 50. My thousands cancel out, and I'm left with 44 over 50, which works out to be about 88%. Now, if I wanted to do the exact same problem a little more informally, I could say that if I still want to find the positive test results given that a subject uses drugs, I could simply look at this and say, I know this is 44, I know the sum of this column is 50, so I know that it's 44 out of 50. That trick might save you a little bit of time. As always, we have additional support for our students. You can find our schedules and tip sheets on our website for the Academic Centers for Enrichment. The Bedford Math Center and the Lowell Math Center are available to help, and E-Tutoring is available 24/7 online. Finally, I will be linking a tip sheet specific to this topic in the description of this video. Thanks for watching.